Hey folks, this is Dr. Emily Scherning with American Resiliency. If you're interested in the climate outlook of any island within the US and territories, this is the video for you. We're going to talk about Hawaii, Puerto Rico, the US Virgin Islands, Guam, the Northern Mariana Islands, and American Samoa. I'm going to warn you straight off the bat, this video has some rough stuff. First band-aid we got to rip off for everyone, sea level rise. We're using a .org tool to look at sea level rise today, thanks to coastalclimatecentral.org for this worldwide, very effective tool. I think it's important that we look at all of the islands for this video at 3 feet of sea level rise. That's in line with what everyone agrees we're likely to see this century, and at 10 feet of sea level rise, where we're more likely to end up if the rate of melting in Antarctica continues to be so dramatic. So you may know that some islands and island nations like Kiribati, which here we're looking at the Tawara Atoll, which is the capital of Kiribati, are extremely vulnerable to sea level rise. At 10 feet of sea level rise, there are inhabited islands that will be lost. As we can see here, we're talking about a complete land loss for this nation. But let's head over to some US territories. Let's go look at Guam. And I think it's worth noting that this tool lets us model up to 30 feet. I know many people have been looking for tools that let them get beyond 10 feet. So this is a great tool for that. And you can see that Guam here looks surprisingly resilient to sea level rise. We're not looking at a tremendous amount of land loss, even in these very serious scenarios. Of course, it will impact the harbor. I'm not saying it's going to have no impact, but I'm saying this is an island that's going to stay on the map. The same is true for the Northern Mariana Islands, where we're seeing damage at 3 feet. We're also seeing at 10, and we're talking about fairly limited areas that will be lost to sea level rise. Significant, but on the map. For American Samoa, it's the same story. At 3 feet of sea level rise, we're talking about damage to infrastructure, damage to the airport. And that looks bad enough that I imagine that they're aware of the potential issue already. At 10 feet, we can really see the strong elevation climb of these volcanic islands and how much of the land area is likely to remain, even in extreme sea level rise scenarios. As we move into a completely different part of the world, we can see that it's a very similar story for the US Virgin Islands, but as we move into Puerto Rico, that's where we start to really see our most vulnerable island so far to sea level rise. We can see that in San Juan, we're talking about a fairly large amount of developed area lost at 10 feet. But moving down to a more conservative scenario, 3 feet of sea level rise, we can see that we have some time to respond to the changes that might be coming over a longer period of time to Puerto Rico. Zooming out a little bit, I just want to highlight the difference between 3 feet and 10 feet. It's really pretty dramatic. So for Puerto Rico, you're talking about having some time to respond, having some time to handle one problem at a time, one step at a time. I think for long range thinkers, this is important because this is a dramatic enough level of potential inundation that I think there's long-term concerns for Puerto Rico related to saltwater getting into the groundwater and saltwater getting into the soil for a fairly large portion of the coast. So now we're looking at Hawaii, and so far everybody else has been an island that is staying on the map. When we talk about the islands and sea level rise, I think that there's a common cultural misconception that they're all going off the map. Nope, all of these are staying on the map. And at 3 feet of sea level rise, we can see that Hawaii doesn't care all that much, except for here, we start to see some real damage to Honolulu, even at 3 feet. And at 10 feet, that does become fairly significant. Zooming out, taking even more of like an extreme bird's eye view here, we can see that Honolulu really is the place where we're looking at the most damage to the built environment from sea level rise, but that by and large, we're talking about extremely resilient, high above sea level volcanic islands where there is going to be a lot of land area remaining. These are islands that are going to stay on the map. I think it's very important to fight this misconception, to know that we're staying on the map, to know that these are places that have a future. And with Hawaii, don't get me wrong, there are going to be impacts from sea level rise, particularly related to freshwater supplies. We expect to see saltwater incursion to groundwater in some places on the Hawaiian Islands, and changes to the beaches of Hawaii may imply logical changes to important habitat and indigenous food systems. So we're talking about reef stress coming from many directions. I'm not trying to minimize here the risks facing Hawaii, the risks facing other islands, but I think it's also important that when we talk about all of these US islands, that we're talking about places where the future matters and that that's a critical baseline. We can see that Hawaii is changing, but it's not going anywhere. And that is true for all the islands. So let's get into some more detail. We're going to come back to Hawaii. First, we're going to hit up the Caribbean and kind of circle around. The source material that I'm going to be using is in the NCA 5, the 5th National Climate Assessment. If you go to chapters, you'll see that chapter 30, we have Hawaii and US affiliated Pacific Islands, and chapter 23 is the US Caribbean. If you want to read all the information in this report, these chapters are easy to download and they're pretty accessible. Unfortunately, part of why they're accessible is that they don't have a lot of technical information. If we look at this figure here, 23.2, which gives us some projections on temperature and precipitation for Puerto Rico, this is the best information that we have available from the NCA 5. And you can see right here that this is a challenging outlook, a drought outlook under either scenario, whether we manage to significantly reduce emissions or not. In terms of precipitation, you can see that there is, especially if we don't reduce emissions, a serious decrease in precipitation projected for Puerto Rico and for the rest of the Caribbean, and significantly more consecutive dry days, longer periods of drought, and that's looking true for both the wet season and the dry season. I think that this consecutive dry days in the wet season is really important, where we can see we're looking at a relatively stable trend if we can get emissions reduced, whereas it's going to be really damaging to that wet season precipitation that's so important for the Caribbean water cycle if we fail to do that. We can also see that in Puerto Rico, your hottest days by about 2C are going to be about 4 degrees hotter. So noticeable, especially in an area where it's already quite warm in the hot season. Those heat increases, even though they're relatively modest in terms of number, they've already been causing ecosystem stress because many living things in Puerto Rico, of course, they like it hot, but they can't tolerate much additional heat beyond the traditional climate. When we start to see heat indexes over 116, which we have been seeing in Puerto Rico, we have already seen an event in Puerto Rico where a forest stopped photosynthesis because of the heat. We have already seen mass insect death from heat in Puerto Rico and butterfly death from heat. So this is very sad and serious information, what we're seeing in those projections. Looking now at figure 23.7 from the NCA 5, this helps us understand the ecosystem stressors that the Caribbean islands are facing and how they connect. You can see there's a cascading series of challenges where the forests are facing stress, like I just described, but also the reefs, the built environment, and importantly, also the seagrass beds. So all of the ocean ecosystems that are so important for island food systems are all facing stress from these changes at the same time. Talking a little bit more about the built environment. So we looked at sea level rise as a flooding type risk. You can see in figure 2310 that flooding risks from rain are serious in this environment. When we're talking about drought and deluge type events, which remember those projections showed longer dry periods, both in the wet and the dry season. So drought and deluge. If you're going to get like 0 rain for a month and then a foot of rain from a hurricane, you're talking about very serious flood potential from rain. And that kind of extreme rain, it doesn't soak into the ground well. It's going to wash over the land. That can be and has been very damaging to the built environment on the islands. And you can see here in figure 23.12 that the response to these threats in the Caribbean is varied. There's a particular lack of systems level response so far in the US Virgin Islands. The people of Puerto Rico and the systems of governance in Puerto Rico are doing a lot more to get ready than we're seeing out of the US Virgin Islands. And there's a real need to respond because the stress is already being experienced, I think a lot of people are just getting by already. They're already fully occupied responding to current challenges. So, this is a difficult picture here, a picture where you can see the intense need for local resources, for pathways to support communities on the ground in the islands. So that's a lot of rough stuff in the projections for the Caribbean. And as you could tell from the figures, there's a lot of variability baked in there. Irregular patterns in the rain, some irregularity in that temperature trend, where you're going to be dealing with a complex picture. I want to show you the hurricane projections before we leave this region. So this is a figure I'm still using from the NCA 4. It wasn't updated in the NCA 5, but we are seeing these late 21st century models starting to take shape now. Over the last couple of years, we've seen this inland hurricane track start forming up. We've seen hurricanes coming in around Big Bend in ways they haven't been before. And we can also see, unfortunately, that there's consensus, to what degree we have consensus around long-term hurricane modeling, that more and more serious, stronger hurricanes are likely to be forming in the Caribbean as we keep moving into a warming world. This is an intense figure. For Puerto Rico, for the U.S. Virgin Islands, we see more hurricanes likely to hit the islands and more bad hurricanes, more Cat 4s and Cat 5s. We have had a couple of bad hurricane seasons these last 2 years, is my understanding. In these conditions, to work together is essential to help each other when help from the U.S. mainland may be increasingly unreliable. In the Caribbean, building community resilience within and among the islands looks just critical. And I know these communities are tight. That is the hope, is the strength of these communities and the resilience of the people in these communities. This need for resilience and self-reliance is, of course, even more so the case for the islands which are further away from the continent. Let's look over to the Pacific Islands. This figure, 30.3, is very important as we look at what we have for the outlook for the Pacific Islands. This figure is showing changes in the rains, the seasonal shifts in the rains anticipated as we approach 3C, so further out than I normally talk about. And you may notice that as we're approaching 3C, we're seeing a lot of increases in precipitation projected for many of the islands. So this is very important in a context where, as we're approaching 2C, we know many of the Pacific Islands have been experiencing drought trends. This figure gives evidence that there are additional changes projected should the world continue to warm. First, in the Pacific Islands, we'll have a drought trend. And then in some cases, we'll have a real reversal, become very wet in many of the Pacific Islands. Knowing that there's the potential for very intense change in more than one direction, I think is important foundational information as we approach these Pacific outlooks. In figure 30.5, we see an overview of ecosystem change from these complex stressors, where just like in the Caribbean islands, we're going to need to be concerned about freshwater supplies. We also need to be concerned about food systems and health systems, as the changes that have already occurred and are likely to continue are likely to increase disease risk from mosquitoes. Mosquito-borne disease has already been devastating for native birds in Hawaii. Mosquito-borne disease is not just a human problem. As we see continued warming, we would expect that the mosquitoes that carry avian malaria would get further up into the mountain sanctuaries, which are now some of the only remaining refuges of native Hawaiian birds. For Hawaii, I want to say water systems are a particularly critical consideration because we're talking about moving forward in a world where the ocean is stressed out, where the reefs are looking pretty bad. So relying on the ocean as the basis of your food system, that could get scary. So you've got to think about how to produce food, particularly salt-tolerant food, which we can see here in figure 30.7. We can showcase that there are traditional crops in Hawaii that are salt-tolerant crops, like many species of taro are salt-tolerant. In a future where we expect a higher level of change in the sea than on the land, thinking about salt-tolerant food crops and working to restore taro agriculture in Hawaii seems like it could be a very smart idea. And if we're going to think about growing food, that means we have to think about water. We don't just need water for people to drink, we need water for growing food. And with irregular rains and potential damage to aquifers from rising sea levels, getting very serious about water conservation, getting very serious about water systems will be critical points for building resilience, especially in Hawaii, where you have such important and beautiful land to hold. When I think about the potentially serious changes to the natural water systems on these islands, of course, when I think of water, I also think of fire. In this figure, 30.13 from the NCA 5 shows current wildfire risks. I think many of us in the continental US have no awareness of what a serious risk wildfire currently is on the Pacific Islands. The reaction that we felt to those terrible wildfires in Hawaii in 2023, I think most of us in the continental US saw that news with great shock. But those of you on the islands, many of you said you saw that threat coming and that you're concerned about the increasing risk of wildfire. Building fire resilience on the islands is going to be important. I think this is a risk where awareness matters a lot because we know that there are things we can do to reduce fire risks to our homes, to our communities, and to beloved lands. On the channel here, you can search for building fire resilience and get a lesson from a professional architect focused on building resilience for the built environment. So you can start your learning about what you can do to reduce wildfire risk today. Let's take just a moment to talk about tipping point outcomes. If we see AMOC collapse happen, we would expect higher end sea level rise, like we visualized at the beginning of this video. Of course, that would impact all the islands, with perhaps the most concern being needed for Puerto Rico, which we have identified as the lowest lying densely populated of the islands we talked about today. In terms of projected precipitation changes, which we can see here in a paper where I've got this link in the video description, like all the other resources as well, we can see that if we see AMOC collapse, the Caribbean looks dry. And we were already talking about them looking dry in a conventional warming scenario. So the islands of the Caribbean would be facing a drought multiplier if we had this tipping point. But check out Hawaii. There's more precipitation projected for Hawaii, only a mild cooling trend that would stay kind of in line with traditional climate. There's no particularly scary colors going on with these figures for Hawaii. So if we are cruising towards a tipping point, if we have hit a tipping point, it looks like Hawaii would potentially pick up a couple of edges to hold as we move into a challenging global future. No matter which pathway we go down, the climate future looks challenging for the islands. We're right on the edge of losing the reefs. Current projections, we're expecting almost total reef loss in the 2030s. Many heroic efforts are being made, particularly in Hawaii, where there are intensive breeding programs. The indigenous people of Hawaii are driving these efforts to help grow more heat-tolerant corals. Reefs are so important. They're not just cool, fun places to go look and see pretty fish. Reefs are critical for fish reproduction. As we lose reef habitats, so many fish species will be unable to reproduce. These are the places where their young can survive, and these places are likely to be lost in the 2030s in almost all climate pathways. What we're talking about with loss to the reefs is very serious, with echoing impacts. Probable loss of the reefs is only one contributing factor to a projected up to 90% drop in what the NCA 5 refers to as ocean biomass. Ocean biomass. All the great life in the ocean, one ugly word. It doesn't seem right to talk like that. It shows that we can think that way. But what that cold number means is that the life in the ocean is going to suffer even more than life on land in these changes that are coming. That is what has happened in mass extinctions before. When our world has gone through previous great deaths, which we do know of those from the fossil record, the dying in the ocean can be very severe. It is not only heat that causes the dying, that is causing the dying now, it is changes in ocean chemistry. CO2 and water combine to make a mild acid. It's just chemistry. I used to teach people about this by having them blow bubbles through a straw into a cup of water, and the CO2 in their breath would change the color of a pH indicator in the water. It's this thing that you can observe in your own hands. It's just chemistry. So if we're putting more CO2 into the atmosphere, we're going to be putting more acid into the ocean. And that dissolves the shells of mollusks, like clams. Clams are pretty tough cookies. They've made it through previous bottleneck events. I think that it speaks very poorly of us that we're taking out clams. We should be looking pretty hard at the choices we're making and what they're costing the future of life. Many living things in the ocean, even if they don't have calcium carbonate shells, they have some stage of their life where they're very sensitive to changes in pH. Many living things in the ocean, if they're not directly sensitive to heat or pH and they don't need a reef, they still need to eat something. And you can tell, if you think about it, there's not going to be much to eat. We are projecting big decreases in many types of living things in the ocean. Many scientists think it is likely that squid will do fairly well and jellyfish. Those are the types of living things they think is likely will survive this great dying in which we are now alive. This is very serious information to consider. The impacts to the oceans, the loss of life in the oceans will impact the islands in so many ways. Food systems, trade systems, but most significant, I think, is the way it will impact the heart. There will be terrible loss, terrible grief for anyone whose heart is connected to the sea. There is a need to build emotional resilience to survive this loss as individuals, as cultures, and as people. There are rich traditions of community, resilience, and survival in all of these islands. Traditional taro agriculture is just one important legacy that could be important for building a resilient future on the islands. For better and for worse, islands are likely to become more isolated in the future. Many of the islands have experienced and are experiencing a relationship with the mainland that is about resource extraction, not sustainability. A relationship that is not based on concern for your future as equal partners. I feel like we see this mentality reflected in the relatively low level of projection information we see in the NCA 5 for the islands, and also in the way the chapter on the Caribbean in particular reads like a lament. I think it is a cruelty to lament one who is alive. Islands are alive, and they deserve a clear focus on the future needs of their resilient peoples. All of you on the islands, when you look to the future, you're on the map. You're places that matter. You are here to stay. No one should be writing you off. But there are cascading changes coming your way. What resilience you can build is going to matter to your future. And that resilience, the more local, the better. Let's get ready. Folks, thanks for watching. I always appreciate you spending some time with me. And I want to say a special thank you to the AR community, because you all are the people who are holding me up. When I need help, when I got questions, when I need an expert on just about any topic, this community is where I reach in. And I want to thank the community for supporting me so that I can do this work. AR doesn't run on grant money. I don't have some secret trust fund. AR runs on your donations. That makes us unique. And the way things are today, that makes us strong. I have many friends and colleagues who work in academic or government jobs, and they're all scared if they're going to be able to keep working. When I wake up, I'm grateful for you all every morning. I wake up and I know I can keep going thanks to this community. And every month, this community is a little bit stronger. We're strong in the way a people can be when we come together. You all are a force. The AR community is the force that is holding up a new way of talking about climate, a way that drives action, a way that brings people together. Thank you for being here with me, and I'll look forward to talking with you all again soon.